Hi, this is Adolph Oliver, and this video clip is about graphing linear word problems. Actually, most word problems, particularly if they're linear here, and that's what we're dealing with now, ones that produce straight lines, can be turned into graphs. And one of the interesting things about these is most word problems just deal with positive values. If that's the case, then we can draw their graphs only needing quadrant number 1, where both x and y are positive. Here's the main idea. We'll talk about it in general here. Here's a quadrant 1. Okay, we can take the x going to the right and the y going upstairs. Notice, of course, the x values are all going to be positive, and so are the y. Well, usually what happens is you have some starting point. It can be a y-intercept over here on the y-axis. And then what you do is step your rise and run arrows off to indicate the slope. Here would be the run, let's say. And then at the end of that arrow, we can put the rise arrow. Here it is. And we get a second point. And we can, of course, turn around now and just connect those points. Well, that's the general idea of what we're going to do. Let's look at some examples now. Okay, here's one where we're talking about roadside auto repair, which charges $40 just to meet you at your car, and then adds $45 for each half hour of repair work. Okay, again, the number of hours here, and they're in half-hour blocks, are going to be positive, and of course the cost is positive. So one thing for sure, again, is we're going to have ourselves a first quadrant plot. So here we go. Now, remember the thing we normally put along the bottom axis is time, and this is going to be in hours. And going up along the vertical axis is going to be our cost, and this is going to be in dollars. Okay, well, remember, we're talking about half-hour blocks, so if I took here and said this was like 1 hour, and this was 2 hours, for instance, then the dots in between here would represent a half an hour, 1 hour, 1.5, and so on. Now, the initial charge of $40 right here. That's just for coming up to the car and saying hello to you. And there's been no time spent at the moment. So this is our y-intercept, our starting point right there. Now, here we go. They're going to charge $45 for each half hour. So what I've got here, let's write it down here, $45 per half hour. Okay, this again is our slope here, good old rise over run, and that means we go over a half an hour, okay, right to here, and then we've got to go up $45. Well, somewhere up here, you've got labels on your axis, and $45, well, let's label this here. Here's our run, equals half an hour, okay, and now the rise here, okay, equals $45. Well, okay, we've done the run 1/2 hour, the rise $45. So at the end of this second arrow is another point, and we can now draw our graph line on here. Here it goes. This, of course, would be $85 right here. Now, of course, we could continue, not that we need to make the line, but here's the next half hour, and then if we go up here for the next $45, then let's see, where would we be? I think at about $130 up here. Okay, so there is how you can do it. You only need one of these rise and run arrows here to get the line, but others would just reinforce it. Okay, that's how we can get the graph for that one. Let's now move on and look at another. Okay, here's one here which is about depreciation. Depreciation is when you're wearing things out and they're decreasing in value. So it says a $24,000 car depreciates, loses values at the rate of $3,000 per year. Well, again, the years are going to be positive, and even though we're going down, the value of the car is still going to be positive. So once again, let's make ourselves an first quadrant plot here. And again, time along the bottom, so since we're talking about years, that'll be here, and the value going up in dollars, and we'll label it thousands. So we only have to put 1, 2, 3, or 4, whatever. Okay, well, let's mark off some years here. This could be 1 year, and the same distance over here, 2 years, for instance. Now, what's the value of the car to begin with? Well, if we had some tick marks on here, labeling values, this could be 10,000, this could be 20,000. 24,000 will be, up about here, and so that's our starting value right there. Y-intercept again, the car is initially worth $24,000 when it's first purchased. Well, now what's happening is it's going down, depreciating at a rate of minus $3,000 per year. Okay, well, we start with the point we know, go over 1 year, here we go, okay, and then minus 3,000. Now remember, we got this labeled in thousands, so we're only going to go down minus 3, and that'll take us down to about, where it is here, about 21. So this will be the run here, 1 year, and the rise here, minus 3, because we've got it labeled in thousands. Well, at the end of this second arrow is another point, and now we can turn around and draw the graph, and it will look like this, heading downhill. Well, you could do more rise and runs, but they would hit the same line going down. So again, what we did was take the starting point, 24,000, we labeled 10 and 20, 24,000 about there, and then did our run of 1 year and our rise of -3. Remember, since this was labeled in thousands, I just went -3 for -3,000. Well, getting graphs like this is not difficult to do. Let's look at another example. Okay, here we go on this one. And it says a van can be rented for $22 per day and 50 cents per mile. Graph the charge for 1 day based on the miles driven. Well, the charge is going to be positive. The number of miles you drive is going to be positive. So once again, you're going to have a first quadrant graph. And now, we always want the values, the cost, to be going upward like this. So what we have now, instead of a time, is the number of miles that have been driven. Okay, now, here we go. We're starting at $22 per day. That's the flat rate, and then they add the mileage charge on top of that. So if this was 10, and this was 20, and this was 30 here, then we've got a range we can work with. Okay, the flat fee, $22 just for the day, even if you don't drive the car. Well, that's going to be at miles 0 right here. And $22 will be about here. Okay, so there is our starting value again. Now, the number of miles going here, remember now, the rate is 50 cents per mile. Now, here's one thing you have to watch out for, and that is you got to have the same dollars notation. So this 50 cents per mile has to be changed into 0.5, in other words, half a dollar per mile. That way we can then plot it right on our axis right here. Well, what would be good on this would be to have a rate for more than 1 mile to make it a little bit easier to graph. So let's say that we multiply top and bottom by 10 here to get us 10 miles. And then what we'd have then is that would be $5 per 10 miles. Okay, well, then that allows us to go out here and make some tick marks going out here. This could be 10 miles, this could be 20. We could have 30 further out here. And every 10 miles, we're going to cost $5 more. Well, here's the starting point right here. So if I come out to 10 miles, and the reason I multiplied top and bottom by 10 was to make it a little bit easier to graph, because we just came out 1 mile, and that would be such a small horizontal distance here. Whereas if we turn around and multiply top and bottom by 10, we've got the same rate here, but it's easier to graph. Okay, so there's our run, equals 10 miles. Okay, now, of course, they're going to charge $5 more. So we were at 22. That'll take us up to about 27. So here's the rise, equals $5. Well, at the end of that, okay, is another point on the line. And now simply come and graph that out. You could make more triangles, but it'd give you the same line here. So here we are. This is the graph line that represents the charge. For 20 miles, you could go up and hit it and come over here and see about what it would be. And if you extended it out here enough, you could play the same game with 30. Come up with 30 and read off what you had. Well, that's the idea of graphs. You make them so that folks can find values rather easily, not the perfect answers, but something close enough. Okay, here's another one. Let's see what we've got going here. It says, after 2 months, the lake was 250 feet deep. Since then, it's become shallower at the rate of 20 feet per month. Okay, so if we just make a little sketch here, okay, here could be our lake right here in cross section. And it was 250 feet deep. Okay, at 2 months. Okay, now what's happened is it becomes shallower at the rate of 20 feet per month. So it's becoming lower and lower and lower as the water evaporates. So the rate that we have here, okay, equals negative 20 feet, okay, per 1 month. Okay, well, once again, the months and the water depth are both going to be positive, so we can make a first quadrant plot. Here it comes, x going this way, y going this way. But now, here's what we want. We've got time again, months, so that's what we put along the horizontal axis. Then how deep the pond is, the number of feet, and it's how deep it is the vertical axis. Now, let's put some months down here. We've got 1 month, 2 months, 3 months, 4 months. Let's label them 1, 2, 3, and 4. Now notice the twist in this one. It said it was at 250 feet, okay, at 2 months. Well, let's label some of the values here in the vertical axis. We might make that 100. We might make this 200. So we're going to be at 250 feet at the end of 2 months. Well, this is 2 months right here. So 250 feet would be right about there. So there's our 250 feet, okay, at 2 months. Well, now, the rate, of course, is rise over run. So from that given point, we run one more month. Here it is, out to month number 3. So there's our run, which equals -1 month, or excuse me, plus 1 month. We're going to the right. But now the rate is negative. So we're going down. Well, we were at 250 over here. Going down, we go down 20. Okay, so the rise is -20. Well, at the end of that arrow, we put another point. We would be at 230 feet. But here we are. We can now use those 2 points to draw the graph line, and it looks like this. Here it goes. So we didn't start over here on the y-axis. We didn't have a y-intercept because we knew it was 250 feet deep at 2 months. So 2 months, 250 feet, here's our starting point. But then we stepped off our horizontal run and then our rise, which was down 20, and drew the line, and there we are, but it started from the one point we knew. Okay, one last example to take a look at here. An economy car can be rented for $12 per day and 40 cents per mile. Well, again, it says graph the charge for 1 day based on the miles driven. Okay, well, the number of miles you're going to drive is positive, and the charge is going to be positive. So, as we've been mentioning here, we get a first quadrant plot. Here it goes. And we want the charge up on the vertical axis here. So, this will be dollars. And the horizontal axis is going to be miles that we're driving. Okay, well, let's put some tick marks on here and see what goes. We've got, let's say, $10 here, and let's say $20 here, and $30 would be up about here. Now, the number of miles driven. Notice that it costs 40 cents per mile. So 40 cents per 1 mile. Okay, now, we always want the units and cost to be the same, so we're going to change this 40 cents to dollars notation, and it will be $0.4 over 1 mile. Now, once again, to make it a little bit easier to be able to graph, let's just multiply top and bottom by 10 here. And remember, this is 1, so anytime we multiply something by 1, we don't change its actual value. Just change what it looks like. So 0.4 times 10 would be a total of $4, and that means we drove 10 miles. So every 10 miles we go, we have to pay another $4. Okay, the initial charge here, just when you got the car and haven't driven anywhere, is $12. So 12 will be right about there. So there's our initial point. Now, let's put some miles out here. Let's say this is 10 and this is 20. So the first thing we're going to do then, we're going to use our little bit larger values here because it's easier to graph. We go out 10 miles. Here we go. So here is the run, which equals 10 miles. Okay, we went from 0 miles to 10. Then we're going to increase by $4 what we had. Now, by the way, notice I made one little slip here. This should have been drawn from the 12 point we have, so don't pay any attention to that line. It's right here. Starting at the 12 that we had, I went to the right 10 miles. Now I've got to go up $4. That's the increase. Well, that's going to take us up to $16. So here we are. Here's the rise, which equals plus 4. At the end of that second arrow, okay, is another point. And once again, here we go, connecting up the dots. There's our line, which tells us how the cost increases as we drive more miles. Okay, watch out for these problems where they have dollars notation and cents notation. Best thing to do is always convert the cents to dollars like we did here, so everything is in dollars notation.